everyone, today we are going to be talking about translations. So the learning objectives are to define a translation, to translate points algebraically and graphically, to write the rules for translations, and to apply translations to functions. So what is a translation in geometry? In math, a translation is when we move a figure, and we can move a figure either left, right, up, or down. Let's take a look at example number 1. So in example 1, we are given 3 points, A, B, and C, and if I graph and connect them, they form this triangle. And our goal is to try to get the coordinates of the new points, A prime, B prime, and C prime. Notice they have that little apostrophe on them to show that they're the new points. Well, if you look at the rule, it tells us exactly how to get those new coordinates. It says take all the x coordinates and add 2 to them. So our x-coordinates are these numbers here in red, 1, 4, and 3. What we're going to do is we're going to follow the rule and we're going to add 2 to each of those numbers. So 1 plus 2 is 3, 4 plus 2 is 6, 3 plus 2 is 5. Now we're going to follow the rule for the y-coordinates. It tells us that they want us to subtract 1 from each y-coordinate. So these are the y-coordinates. We're going to take away 1. 2 take away 1 is 1. 1 take away 1 is 0. 5 take away 1 is 4. So this produces the new points that we can now graph. So let's go over here and graph it on the same plane. 3, 1, and that's our A prime. So be in the good habit of labeling your points. Now 6, 0 is our B prime. And lastly, C prime is at 5, 4. Let's connect these points to form a triangle. Okay, so if you can see, our original triangle seemed like it moved over here. So the question is, which direction did it move and by how much? So it kind of looks like it moved right and down, right? But let's see by how much. So if you're not sure, you can take a look at one of the old points and see how it got to the new point, and that will show you exactly how this triangle moved. So if we go from C to C prime, it moved to the right 2 and down 1. In fact, it's done that with all the points. We can check for point A, go right 2 and down 1, and we are at A prime. And if we go to B, and we go right 2 and down 1, that's B prime. It moved all the points in the same way. So the net effect is that it moved our figure right 2 and down 1. Well, if you look at the rule, it's going to actually reveal that already. So here, do you see how it says x plus 2? Well, think about it. Which direction does the x-axis go? It goes left to right. So it makes sense that it would move our points either left or right. And because it's positive 2, it moves our points right 2. And the y-axis goes up and down. So it would make sense that it would go down 1 since this number is minus 1. So it seems like we can tell how the figure is going to move just based on the rules. Let's practice and see what's going to happen to the figure by just looking at the rules. So in this first one, plus 6 is applied to x. Remember, the x-axis is left to right. So since it's positive, this must move it right 6. Here, x is being subtracted by 3, so it must be going the opposite direction, left 3. Here, 4 is being added to y, which the y-axis controls up and down, so this must move it up 4. And lastly, y minus 9, that must make it go down 9. So if you look at the translation rules, you can see what's going to happen to the figure. So that gives us a new way that we can do problems. All right, let's use that knowledge in example number 2. instead of doing this algebraically, subtracting 3 from all the x coordinates and adding 4 to all the y coordinates, which you can do, but let's just take a look at the overall effect. Well, x minus 3 must move it left 3, and y plus 4 must move it up 4. So if we know that, we can actually go to the graph and graph the new points already. So let's go to point A. Well, from point A, we need to move left 3 and up 4. We're going to write our new point right there. And we do that to every single point. Now we go to B, go left 3 and up 4. And C, left 3, 1, 2, 3, up 1, 2, 3, 4. And then we can connect these points. Ta-da! And here's our new figure. All right, and lastly, we just need to write the coordinates of the new figure so that we can finish solving the problem. So here, A prime is at the point 0, 3. B prime is at the point negative 1, 1. And C prime is at the point 1, 0. And we've accomplished this problem in a new way. So you can do the problems either way, whatever's easiest for you. All right, let's take a look at example 3. So Andy thinks that the original figure, this one, line segment AB, has translated up to and right 4. Do you agree or disagree? Why? So let's take a look at Andy's work right here. He clearly shows us that this has gone up 2 and right 4. So is he correct? Did this shape move up 2 and right 4? If you said no, you are correct. So let's see what mistake Andy did. Well, he was looking at original B to A prime. What he should have been doing is looking at the original B and going to B prime. So let's see how it actually moved. It didn't move just up 2, it moved up 1, 2, 3, 4, 5. So it actually moved up 5 and to the right 1, 2, 3, 4, 5, 6 spaces. All right, so then the next question is, can we write a rule for this translation? Okay, no problem. We know that translation rules start out with x, comma, y in coordinate form, an arrow, and then a rule for what happens to the x coordinate and the y coordinate. So remember, x goes first, and x controls left or right. So in this case, he went right 6. So it's going to look like this, x plus 6. And then next, the y controls up or down, and it went up 5. So it will look like y plus 5. And this is the rule that describes this particular translation.